Hi, I'm Ms. Vung. Today we're going to look at gradient of a straight line. Here I have 5 equations, and for each of these equations we're going to plot 2 coordinates and draw a straight line. After that we're going to compare and see what they look like. For the x value of the coordinate, I picked 0 and 1 just because it's easy to evaluate. If you remember how to do this, then you can pause the video and try it yourself first and unpause to check your answers. If you've forgotten, you can click on the little I in the corner there and it will take you to the video where we do this. So to evaluate the first one, when x is 0, y equals x, so y equals 0. When x is 1, y equals 1. For the second one, 2 times 0 is 0. 2 times 1 is 2. For the third equation, 5x, when x is 0, we also have 0. And then when x is 1, 5 times 1 is 5. For the fourth equation, when x is 0, 0.5 times 0 is 0. You can probably see the pattern here. Then 0.5 times x is 1 is 0.5. And lastly, 0 and 0.1. So let's sketch these. 0, 0, 1, 1. 0, 0, 1, 1. So the first line is y equals x. I'm just going to put an equation there so we can compare them. 0, 0, 1, 2. 0, 0 is here. 1, 2 is up here. And then draw a line through those 2 points. 0, 0, 1, 5. So 0, 0 and 1, 5 is there. Draw a third line. Write the equation. And so on. So 0, 0, 0.5. So 0, 0 is there. 1 and 0.5 is up there. That purple line over there. 0, 0, 1, 0.1. So 0, 0 is in the middle. 1, 0.1 is a point just above the x-axis. So it's going to be very, very flat. Or in other words, we like to describe these purple lines to be quite easy to walk across as shallow. Think about walking up a hill or walking across a flat surface. And the pink lines, we can see that they're very steep. So these words here are describing the gradient of the line. We can analyze this by looking at the line y equals 2x and the line y equals x to simplify what we're looking at. So for example, the 2x, we can see that for every time we go across 1, we're going up by 2. Whereas the 1x, every time we go across 1, we've only gone up by 1. So we're looking at how much we're going up, or in other words, rise, and how much we're going across, or in other words, run. So let's analyze the line y equals 2x. Let's pick this origin point and the next point as 1, 2. Then looking at these 2 points, I've gone up 2 and then across 1, or rise 2 over run 1. And it doesn't matter if I pick this point and that point. I'm always going up 2 and across 1, or this point and that point, up 2 across 1. We call this gradient. So the rise is 2, the run is 1. And it doesn't matter which 2 points we pick. We might pick the origin and let's say that point over there, 2, 4. Then we've gone up by 4 this time. So rise 4 and run by 2. And we notice that 4 over 2 is also 2. So it doesn't matter which 2 points we're picking on the line. It will always give us 2. So the rise over run, that ratio is always going to give us 2. So in summary, we can see that if we picked the point 3, 6 and the point, say, 1, 2, to calculate the gradient, we've gone up, the rise, over the run. How do we get the rise? How do we get 4 from these 2 points? Looking at 3, 6, 1, 2. So it's how much y value has increased. So it's got to do with 6 and 2. Or in other words, we took 6, take away 2 to get the 4. And how do we get the run to be 2? It's how much we've gone across, so that distance there. So in other words, we've taken that y value minus this y value for the rise, and we've taken that x value minus that x value for the run. And it's pretty tricky to talk about this and that, so we can label that one as x2, y2, and this one as x1, y1. And therefore, that 6 minus 2 is that y2 take away y1, and the 3 minus 1 is x2 minus x1. And so our equation is y2 minus y1 over x2 minus x1. So if you've seen this equation, you can see that the top is the rise, the difference in y, and the bottom is the run, the difference in x. We represent the gradient as the letter m, rise over run, and it is the difference of the y values over the difference of the x values. Now, in this equation, where did we see the gradient? We notice it's the number in front of x. Let's see if you can spot the gradient in this equation. The gradient is 5. Let's check the rise over run. So we go up 5 between these 2 points, across 1. 5 over 1 is 5. Pause the video and see if you can figure out the gradients of these lines over here. So here we have the rise is 3, the blue number, and run is 3. So 3 over 3 is 1. The gradient for that one is 1. Here we have the rise is 3 and the run is 5. So the gradient is 3 over 5 or 0.6. So here we have a rise of 4 over a run of 2. So 4 over 2 is 2. For the last one, it's quite tricky. We've gone from this point to this point. We've gone down by 5 and across 3. Or in other words, minus 5 over 3, which is minus 1 2/3. Try these out and then unpause to check your answers. So for the first one, we have 1 over 1, so 1. For the second one, we have 3 over 1, so 3. And for the last one, we have a rise of 1 over the run of 2, so a half. Let's do this one using our two methods. So let's pick 2 points first. So we've picked numbers that are whole, so it's easier for our calculations. Now we can see that from this point to that point, we're going up by 1, 2, 3, 4, and a run of 2. So 4 over 2 should be 2. But let's try the equation. So we label x1, y1, x2, y2, and then we're trying to find the difference in y. So 5 minus 1, and then for x2 is 4, x1 is 2. So we get 4 over 2, which is 2. So we can use the equation, or we can just count the boxes. If you don't have boxes to count, then you have to use the equation. Try this one and pause, and unpause when you're ready. So remember, it doesn't matter which 2 points you're picking. I'm just picking values where I can see that it's easy to read off. So again, we do y2 minus y1, which is 4 minus 2. And then we do x2 minus x1, which is 2 minus 5. So we have to be careful that 4 minus 2 is 2, but 2 minus 5 becomes 2 plus 5. So we have 2 over 7. So previously we've worked out that the gradient is also the number in front of x in the equation. So let's look at some equations and see if we can identify the gradient. So for this one, it's pretty easy. The number in front of x is 2, so the gradient is 2. For this one, the number in front of x is, or the number that multiplies by x is, a quarter. For this one, the number in front of x is minus 3. Make sure you include the negative. For this one, the value in front of x is invisible, but it's definitely not 0, otherwise x wouldn't be there. The number is 1. For this one, it's not arranged in the correct order. We have to rearrange that y is by itself on the left. So let's do that. So now we have y equals 10. Bring the x over the other side, becomes minus x. So our gradient, the number in front of x, is actually minus 1 and not positive 1 like it looks like here. So remember to always have y on one side. So the gradient here is minus 1. And for that last one there, again, it's not in the right order. We need y by itself on one side. So first of all, we can bring the 4x to the other side. So now we have 2y equals 6 minus 4x. Now we like the format where the numbers is last. So let's just move these two around. We haven't done anything to it. Just swap these two numbers, the order. Now we need to get rid of the 2. So now we have to divide both sides by 2. So we get y equals minus 2x plus 3. So we divided by 2 all across that line there. So the gradient for this one is minus 2. So whenever you have an equation, always remember y has to be on its own. And then you can look at the prenumeral in front of x. Let's practice a little bit more. By now you can give it a go and probably get it correct. So I've picked that value there, and the other value I'm going to pick will be that one. It doesn't matter which one you have picked. If you've used the same method, you should get the same answer. So using the formula, we get y2 is 3, take away 1 for the rise, and for the run we have 1, take away 2. So we have 3 minus 1 is 2, 1 minus 2 is minus 1. And we always like to write it as a simplified form, so the minus goes on top. So we have minus 2. So we notice that this value is negative and the line is going down. Whereas all the gradients here, 5, 2, 1, 0.5 and 0.1, were all positive and the lines were going up. So you're reading left to right, so up. And we notice that we said when the value is big, like these ones, it's very steep. And when the value is less than 1, it's very shallow. So let's summarize those keywords really quickly. So looking at these lines, we can see that that one is also steep, but negative because it's going down. And the purple line, it's easier to go across. It's negative because it's going down. It's shallow. Whereas we're looking at the positive lines, the lines that are going up, we can see that purple one is not very hard to go across, whereas this pink one, it's pretty hard to go upwards. So that pink one is steep and that purple one is shallow. Now the ones that are going down, that blue one and then the dark blue and the dark purple are called negative, and the ones that are going up, so the pink one and the black one and the light purple one, they're going up, are called positive. So quite a few words there. So a couple more things and then we'll summarize all the keywords and clarify that. When we have a line such as y equals 2, so this time we have no x, then we notice that it doesn't matter what x is because there's no x there, the y value is always 2, so then the line's going to look extremely flat. And because the value in front of x is non-existent, or in other words 0, the gradient for this one is 0. Whereas if we had a line with x equals 3, no matter what y value we have, x will always be 3, the line would be a vertical line. And if we thought about it as rise over run for this one, the rise is infinite over a run of 0. And because we're not going across, and anything divided by 0 is undefined. So x equals kind of equations have the gradient to be undefined, compared to lines where the rise for this one is 0 because we're going up nothing, but the run is infinite. So rise of 0 over infinite, 0 over any number is 0. So the gradient for this one is 0 and the gradient for that one is undefined. Let's see if you remember the important keywords that we covered today. First word, steep. Which of these lines are described as steep? I would say this one and that one. Which of these lines would you describe as shallow? These two are the shallow lines, which have a positive gradient. So the ones that are going up, positive. Those two, that one and that one. And which graphs would you describe as negative? Those two there. A silly way to remember it is when you feel positive, your mood is up. And when you feel down, so going down, your mood is quite negative. And then how would you describe these two? What are the gradients for them? That one would be undefined and that gradient is 0. And for the formula that you have to remember today is that the gradient is m, or the value in front of x. And we have the formula y2 minus y1, which is the rise, over x2 minus x1, which is the run. So write these down in your notes and make sure you understand all that you can see right now and memorize the keywords. Thank you for watching and see you next time.